Good morning, students. Once again, I welcome you to my video lectures on network analysis. And now I am continuing with type 2, type 3 problem. So lastly we had a type 2 where the voltage source was connected between reference node and non-reference node. Now type 3. In type 3, in type 3 you will find voltage source being connected between two non-reference nodes, between voltage source connected between non-reference node, and the method is called supernode method. The method is called supernode method, parallel to super mesh method. You can also work out by other method, not exactly supernode, but for that method we have to mark current through the voltage source. But if you follow supernode method, you need not have to mark any current through the voltage source connected between two non-reference nodes. That is the advantage. Supernode is very easy to follow. Now we know what is node. What is node? Principal node is a junction where three or more branches are connected. So extend the same principle to what is known as supernode. Supernode, it will have a collection. Okay, you can form what is called as a cloud. Okay, I will form a cloud. In that cloud you will find many junctions. Now first, as usual, number of nodes 1, 2, 3. So 3 minus 1 node pair voltages exist. Mark them. V1, V2. This is reference node. This is reference node. Now how many unknowns? Two unknowns. 1, 2. And you can express, first you have to relate node pair voltages. So in type 3, you have to relate the node pair voltages. So V1, V2. Now this is plus, this is minus. Therefore, what is V1 minus V2? V1 minus V2 is equal to 5. So this is preliminary. First, relate node pair voltages, and V1 minus V2 is 5. That means two unknowns. We had two unknowns. So we expected to write two equations, but we know that due to this connection V1 minus V2 equal to 5. Suppose if this polarity were to be reversed, then V1 minus V2 equal to minus 5. Now this is equation number 1. Now how many, another equation, how to get the other equation? The other equation you can get by applying KCL to what is known as supernode. I will show you how to form supernode. Now this is voltage source connected between this point and this point. So encircle that. So you have encircled the end connections. Okay. So it is like this. This is like a cloud. So within this, now I will show you. Now we have to mark currents in all the branches. So mark currents as you like. 1, 2, 3. I have marked current in all the branches, and this point coincides with this. This point coincides with this because there is a short circuit. Now I will show the external connection to this cloud. 4 amperes. Next, this current. Next, this current. And this current, that is 9 amperes. And you need not have to take this because both the ends are inside this cloud. For this resistor, the end points are within the cloud. Within the cloud, no point in representing that. So only you have to show these connections. 1, 2, 3, 4. 4 connections. Now you write expression for these currents. So how to write expression for this current? This is V1. V1 minus 0 divided by half. V1 minus 0 divided by half. Half. This is what is called as supernode. Supernode. Next one, this 5 volts is also within the cloud. Okay. Next, this current expression V2 minus 0 by V2 minus 0 divided by 1 by 6. Next, this current is 9 amperes. Apply KVL. KCL. If you apply KCL, this is incoming current, 2 outgoing currents. 2 incoming currents, 2 outgoing currents. Incoming currents 4 plus 9 is equal to outgoing currents V1, forget about 0, V1 by half plus V2 by 1 by 6. V2 by 1 by 6. Therefore, 13 is equal to 2V1 plus 6V2. This is second equation. 2V1 plus 6V2 is equal to 13. This is second equation. Now solve the two equations. Solve the two equations. First one, 1 minus 1, 5, 2, 6, 13. Now V1 is coming out to be 5.38 volts, and V2 is coming out to be 0.38 volts. Now the voltage drop across the current source is as good as V2. What is V2? V2 is 0.38 volts. This is the answer. So this is how you have to work out supernode problem. In the tutorial, I will work out more problems. Thank you.